Hello everyone, in this video we are going to discuss the short answer questions of the chapter Logic and Science of Block 2 of the paper Humanism and Logic of Srinarayana Guru Open University. So let's begin. First question, what is the role of induction in science? Induction plays a crucial role in science by allowing scientists to draw general conclusions or theories from particular observations or instances. By observing certain patterns in specific phenomena, induction enables scientists to arrive at definitions and explanations about the essential nature of things. Inductive reasoning is used to formulate hypotheses and theories based on observed regularities. It is an ampliative reference where the conclusion goes beyond the given information. Induction is a key component of the scientific method, laying the foundation for further testing and refinement of theories. Second question, how does science use deductive reasoning? Science employs deductive reasoning to derive conclusions with certainty from a set of premises, often involving natural laws or well established theories. Deductive reasoning is exemplified in the deductive monological model of explanation, where explanations are derived through valid deductive arguments incorporating at least one general law. In this model, the explanation must be a valid deductive argument and the premises must contain at least one general law. Deductive reasoning allows scientists to make predictions and test the consequences of their theories rigorously. It plays a crucial role in the logical structure and systematic development of scientific knowledge. Third question, what is the familiarity model of explanation? The familiarity model of explanation suggests that good explanations make unfamiliar phenomena familiar or understandable. According to this model, certain phenomena do not require explanation because they are already familiar and expected. Explanations in this context aim to connect unfamiliar occurrences with familiar concepts or models, making them more comprehensible. For example, explaining various aspects of heat by relating to the kinetic theory of gases, which models molecules as tiny billiard balls, making the phenomena more familiar and accessible to understand. Fourth question, what is the significance of the deductive monological model of explanation? The deductive monological model, also known as the covering law model, is a significant model of explanation in science due to its vigorous logical structure and emphasizes on the role of laws. This model highlights the importance of natural laws and deductive reasoning in providing scientific explanations. By subsuming a particular phenomenon under a general law or set of laws, the DN model aims to provide a logical and systematic account of why that phenomenon occurs. The model emphasizes on deductive validity and the inclusion of at least one general law aligns with the traditional view of science as a logical and law governed enterprise. Fifth question, how does aesthetics influence scientific reasoning and theory choice? Aesthetics, or the sense of beauty and taste, plays a significant role in influencing scientific reasoning and the choice of theories. Aesthetic considerations often guide scientists in selecting, testing, and justifying theories they find appealing or elegant. Many scientists have acknowledged that their aesthetic sensibilities not only influence their work but also motivate their study of natural phenomena. Aesthetic values shape scientists' decisions about which theories to pursue, test, and ultimately accept or reject. The perceived beauty and elegance of scientific theories, models, and mathematical proofs contribute to their appeal and acceptance within the scientific community. Sixth question: what is the theory of theory ladenness and how does it relate to subjectivity of science? The theory of theory ladenness posits that all observations and investigations made by scientists are influenced by their theoretical presuppositions and pioneer understandings. According to this theory, there are no purely objective scientific facts that scientists observe and build theories upon. Instead, observations are shaped by the individual scientist's background, experiences, and conceptual framework. This theory highlights the subjective aspect of science as different scientists may interpret observations differently based on their unique perspectives and biases. The theory of theory ladenness challenges the notion of science as a completely objective endeavor and introduces a creative and imperative dimension to scientific practice. Seventh question: how does the reason model of explanation work? The reason model of explanation involves searching for reasons or causes to explain why something happened. In this model, the occurrence of a phenomenon is explained by providing the reasons or causes behind it. For example, what asked to explain why something occurred, scientists might search for the underlying reasons or causal factors that led to that particular event or observation. If not clear reasons can be identified, the occurrence may be considered accidental or unexplained within the context of the reason model. Eighth question: what is the role of inductive reasoning in science? Inductive reasoning plays a crucial role in science by allowing scientists to formulate general theories and conclusions based on specific observations and instances. Through inductive reasoning, scientists identify patterns and regularities in observed phenomena and use these patterns to develop hypotheses and general principles. Inductive inferences are ampliative, meaning that the conclusions go beyond that given information, making inductive reasoning a key component of theory formation and scientific discovery. Induction lays the groundwork for further testing and refinement of scientific theories through deductive reasoning and experimentation. Ninth question: what is the causal model of explanation? The causal model of explanation focuses on providing information about the causal history or sequence of events that led to a particular phenomenon. Unlike the deductive monological model, the causal model does not necessarily require the positing of a natural law. Instead, it aims to explain a phenomenon by tracing its causal antecedents and the chain of events that ultimately resulted in the observed occurrence. The causal model emphasizes the importance of identifying and understanding the underlying causes and mechanisms that give rise to particular phenomena. Tenth question: how does science aim to provide explanations for natural phenomena? Science aims to provide explanations for natural phenomena by ruling out supernatural or mystical accounts and instead offering rational and empirical grounded explanations. Historically, science has sought to demystify natural occurrences by uncovering their underlying causes and mechanisms through scientific observation, experimentation, and the formulation of theories. The scientific enterprise lies in its ability to explain phenomena in rational terms, moving them from the realm of the unknown to the known. Science strives to reveal the depths facts of the natural world and uncover the mysteries of the universe through rigorous investigation and logical reasoning. These are some of the important short answer questions of the chapter Logic and Science of Block 2 of Humanism and Logic. In the next video, we will discuss about the paragraph questions of the chapter.